Good morning. I'm Joseph Peretti, and I'm an AI and high-performance computing consultant focusing on especially the health science vertical segment. Today, I'm going to talk about some work I've been doing on large language models, retrieval augmented generation in the AWS cloud. So my work is about a serverless retrieval augmented generation system built on AWS using Facebook AI similarity search for vector search and Bedrock, which provides flexibility of LLM choice as well as enterprise features and different models for servicing the query as well as for embeddings. The data set is a corpus of about 3,000 financial press reports, which I've put together over time, mainly from Wall Street Journal, but also from Barron's, Frankfurt Allgemeine Zeitung, and other press reports. The topic is most of the time financial topics. This runs on AWS Lambda. It stores indexes in S3 storage and exposes an API endpoint. The goal was to build and deploy a cost-efficient system, one that can be extended into an agentic application. So in 2025, I started working on a similar project using Llama 2 billion parameters model running on my Ubuntu PC, but there were limitations, just 6 GB of GPU memory, so I had to do things like quantization and 4-bit quantization, and also use lower quality embeddings. There were also documents truncation to 1,000 characters because of resources limitation. So the results were, as you can expect, suboptimal, although the system worked from input to output standpoint perspective. The goal here was to remove these constraints, and that's why the cloud environment was the only feasible solution. Full precision, state-of-the-art models, such as Claude Sonnet, and also build something that could run in production. And the other thing is that this system is the foundation step for a full-fledged agentic application where the system can reason, use tools, and handle more complex multi-step queries. Here I'm going to talk about the architecture of the system, which is fully serverless with 3 Lambda functions that form a pipeline. When a PDF file, one of my many press articles, is in the S3 bucket, it triggers the document processor, which extracts text using PyPDF. It does chunking into 1,000 character segments with overlap, and generates embeddings using Bedrock Titan model. The chunks trigger the index manager, which is also a Lambda-based program, which rebuilds the FAISS, Facebook AI similarity search index, and stores the index in S3. On the query side, the users access the API gateway endpoint, which is also secured with an API key. This will be more clear from the demonstration. The query handler Lambda loads the FAISS index from S3, performs similarity search, and then passes the retrieved context to Cloud Sonnet 4.5 via Bedrock for answer generation. So the cost concern was pretty high in developing this proof of concept, and so I evaluated two options: one with OpenSearch and one with FAISS. So as you see in the table, the VPC option is pretty expensive, in the order of maybe $100 to $150 per month. OpenSearch is native in AWS. So I went for Facebook AI similarity search in S3, which drops the cost of a couple of orders of magnitude. So for prototypes, this is okay, and this kind of cost comparison can often make the decision, the decision between approved or non-approved projects. So in terms of design, I went for FAISS with index flat IP, which is the simplest index type, which compares the query against every stored vector to find the exact matches. So this is kind of brute force approach, which is fast enough for smaller data sets. So for 100,000, I have actually fewer vectors than that. If you go beyond that limit, you may find the need for different algorithms. The index is stored in S3 as a binary file, and it loads into Lambda memory when the function starts, and it stays in memory across subsequent requests. Chunking, 1,000 characters with 200 character overlap. The documents are split up into overlapping chunks at sentence boundaries, so the queries match complete thoughts rather than fragments. For the embeddings, I'm using the Python model, 1024-dimensional embeddings. These are for capturing semantic meaning using a model which is also integrated in Bedrock. And Cloud Sonnet 4.5 via Bedrock for answering the user's query. There were some operational issues during the development. Lambda layer compilation, NumPy and FAISS need many Linux wheels matching the Lambda runtime. So there was a mismatch of Python 3.8 locally installed versus required 3.9. So that involved rebuilding the layer dependencies with the appropriate parameter for the pip install command with the many Linux wheel that you see in the title. S3 metadata must be ASCII, so this is an issue that appears especially because there are German articles with umlaut in the data set, and so this titles must be ASCII. And so there is code in order to make provisions for that. S3 event notifications are not retroactive, so So if you load additional files, you have to rebuild the index. So basically, you have to delete the files in S3 and then use the appropriate script to upload the PDF files. Concurrent Lambda limits saturated during bulk ingest. This was not, there's no root cause solution for that. However, successful queries suggest that it was resolved through iteration rather than through architectural fixes. An important issue was about pagination. So maybe there is quite a lot of detail in this slide, but the key point is that there was a need to support pagination in code because the default behavior is unpaginated, and this issue became apparent because the number of vectors was found to be way below what one would expect by simple, back of the envelope calculation. So in terms of the performance of the system, it's a non-exhaustive set of tests, but I am listing here 3 representative cases. The first one is about temporal retrieval. So my data set spans 2020 to 2026 timeframe, and it was about the Federal Reserve in the United States rate hikes across this time frame. It pulled documents spanning 2021 through 2024 with specific figures that can be traced back to the source documents. The second bullet is about handling misleading questions. So I was asking a query with a false premise that the Fed loosened policy after 2022 to fight unemployment. The system did not accept the framing. It retrieved articles describing the actual rate hikes in the 2022 to 2023 timeframe as measures to combat inflation, and also the rate cuts in 2024. The third bullet is about cross-language retrieval. The corpus contains English, German, Italian documents. So an English question about cryptosystemic risk also exposed German documents alongside English documents from Wall Street Journal. The Titan embedding model is multilingual, and it matched them semantically. So Claude summarized everything in English without any need for separate translation. Here you see a sample query. We passed a JSON query, and you will see that also in the demo, about the Federal Reserve rate hikes in 2022 and 2023. And we are requesting the top 10 relevant chunks. The response is an answer breaking down the timeline year by year. 3 rate rises in 2022, 0.75 percentage point increase by October. Interest rates reaching 2.75% by the end of 2023. And it also explains the purpose: to combat inflation and pandemic stimulus and slow economic activity. So you can see the sources with similarity scores. The top hit is a Wall Street Journal about COVID-19 variant impacts on rate expectations with an 0.58 similarity score, followed by other articles with lower scores on Federal Reserve projections and bond yields. So now I'm going to demonstrate the system live. So moving here to the demo. So you have an endpoint. So I actually access the system using an endpoint, which is exposed as an environment variable, and there is also an API key. So the query is about what was the most critical impact of coronavirus on financial markets, the relation of treasury yields, inflation. And so the system responds that in March 2020, there were several severe market disruption with $56 billion fleeing bond funds and interest rates on short-term corporate debt surging to 2.43% point above the federal fund rate. And later you see in the response, you see the source from Wall Street Journal and other sources from the Barron. So coming back to the demonstration, in terms of limitations of the system, we have no incremental index updates. So when new documents arrive, we have to rebuild the entire FAISS index. So this is doable because we have a limited number of documents, like 3,000 documents, but it will not scale for very large data sets. So we'll have to do something different. So I did not do any formal benchmarking. These are just some, tests on different queries. There is no deduplication, so the same story, the same article may appear multiple times and could dominate the results. Observability is not implemented. So, for example, CloudWatch dashboards, distributed tracing. These are things that are available in Bedrock and can be implemented in the next agentic solution. No relevance threshold. The system returns the top K chunks regardless of the question and the similarity scores. Of course, the relevance, if you ask a question which is completely unrelated to financial matters, you will get very low scores, right? But you will always get scores. However, I've made some tests and the system is clear enough to say, well, I cannot really handle this kind of question because it is beyond the scope of the data set, which was intended for. And the last bullet is about features like query planning and so on that will be implemented in the agentic system. So the next steps are, building an agentic system where the current system is a worker wrapped up as a query endpoint. The whole system will be built on small agents, which support query planning through code agents by means of Python code. It also supports iterative retrieval because the agent loops and call the RAG tool, call another worker agent, which is a more generic language model, and then integrate and organize the response. It also supports tool integration and agent memory in multi-step reasoning. It will also be based on Lambda. In particular, I'm going to use an asynchronous model of submit poll to resolve the limitation, the timeout limitations of API gateway as well as Lambda, which is 15 minutes. So in terms of references, there is a technical report that details the implementation steps of the system, which is available in a GitHub repo. And the last bullet is the prototype I mentioned earlier on a language model implemented with quantization on a local personal computer. Thank you for your attention.